Hi and welcome to John's Maths Book. In this video, we're going to be looking at how to find the equation of a tangent to a curve using differentiation. If you like the video, then please hit the like button, and I'd be delighted and honored if you'd subscribe to the channel if you haven't already done so. Without further ado, let's go over to the whiteboard. Suppose we want to find the equation of a tangent at a point on a curve. How do we do it? This is best illustrated by example. On the left hand side, I've drawn the graph of y is equal to x squared plus 2. And I've drawn a tangent to the curve at point x equals 1 and y is equal to 3. Given just this information, what is the equation of the straight line formed by the tangent? We know that the equation of a line is given by the formula y equals mx plus constant c, where m is the gradient or slope of the line, and c is a constant where the line cuts the y-axis at x equals 0. In an earlier video, I demonstrated how to calculate the gradient of a line using rise divided by run. When using this method for calculating the gradient, we were given 2 points on the line. We could then use these 2 points to calculate the gradient of the line by using the formula m for gradient is coordinate y2 minus y1 divided by coordinate x2 minus coordinate x1. In our example though, we have just one coordinate. In this case, we can use differentiation to find the gradient. So if y is equal to x squared plus 2, the derivative of y with respect to x, dy by dx, is equal to 2x. So now to find the gradient of the line, we plug in the x coordinate that we know. So in this case, the gradient m is equal to 2 multiplied by x. And x in this case is the value of 1. So it's 2 multiplied by 1. The gradient is 2. So now we have the gradient of the line. We can plug this information into our equation y is equal to mx plus c. So y is equal to m, which is the gradient, which we know is 2, multiplied by x plus a constant c. We also know an x and y coordinate of this line as it touches the curve y is equal to x squared plus 2 at the point 1, 3. So x is 1 and y is 3. So if we substitute the values of x equals 1 and y is equal to 3 into this equation, we can determine what the constant value is. So if y is equal to 3, we have 3 equals 2 times 1 plus the constant c. So if we solve this equation, c is equal to 1. So substituting this value of c back into our equation of y is equal to 2x plus c, we have y equals 2x plus 1. And this now gives us the equation of the tangent to the curve of y is equal to x squared plus 2 at the point 1, 3. So now let's take a look at another example. Let's find the equation of the tangent to the curve of y is equal to x cubed plus 2x squared plus 1 at coordinates x equals 1 and y is equal to 4. So firstly, let's find the gradient or slope of the line by differentiating the function with respect to x. So dy by dx is equal to, so the derivative of x cubed is 3x squared plus the derivative of 2x squared is 4x. So therefore we have our gradient m is equal to 3x squared plus 4x. So our coordinate x equals 1, the gradient m is 3 times 1 squared plus 4 times 1, which equals 7. So now if we plug this into the equation of a line, which is y is equal to mx plus c. So in our case, y is equal to the gradient m, 7, multiplied by x plus constant c. So now if we plug our coordinates x equals 1 and y is equal to 4 into this equation and solve for c, we get a value of y, which is equal to 4, is equal to 7 times x, which is equal to 1, plus c. So solving for c, we get c equal to minus 3. the equation of the tangent to the curve y is equal to x cubed plus 2x squared plus 1 at coordinate x equals 1 and y equals 4 is y equals 7x minus 3. So looking at another example, let's find the equation of the tangent to the curve y is equal to x squared divided by 2 plus 3 at coordinates x equals 2 and y is equal to 5. So first, let's find the gradient of the tangent. We do that by differentiating y is equal to x squared divided by 2 plus 3. So dy by dx is equal to 2x divided by 2. So our gradient m is equal to x. So at coordinate x equals 2, the gradient m is equal to 2. So putting this into the equation of our line, which is y equals mx plus c, we get y is equal to 2x plus c. So our coordinates x is 2 and y is 5. We can use these to solve this equation for our constant c. So if y is equal to 5, 5 equals 2 multiplied by 2 plus constant c. So solving for c, we get c is equal to 1. So now if we put all this together, we have y is equal to 2x plus 1. This gives us the equation of the tangent to the curve y is equal to x squared divided by 2 plus 3 at the coordinates x equals 2 and y equals 5.